Hey guys, so in this video we're going to learn about how ionic and covalent compounds dissolve in water. So before we start, let me just review the difference between ionic and covalent compounds. So an ionic compound is made up of metal and a nonmetal. So remember, on the periodic table, the metals are everything to the left of this diagonal staircase line. And the nonmetals are to the right. Now there are some metalloids in there, but don't worry too much about those for this section. Nonmetals, metals, except for hydrogen is a nonmetal, even though it's on this metal side. So ionic compounds are a metal and a nonmetal. Covalent compounds are just nonmetals. So we're going to talk about ionic compounds first. And I'm actually going to use crayons because I'm going to do a little sketch. If you're taking notes at home, you can get out some crayons if you want, or just do your best. Just write in pencil or pen if you want to. So this is going to be kind of a key up here. So I'm going to draw sodium as kind of like a blue circle. And I'm going to draw chloride as a green circle. And these have charges because they're ions. Sodium is in the +1 column, so it forms a +1 ion when it forms an ion. Chlorine is in the -1 ion, column, so when it turns into the ion chloride, it's a -1. So I'm going to go ahead and label the charges here. Sodium is positive, chloride is negative. Now for my water, I'm going to use kind of a reddish pinkish color for oxygen. It's pretty common to use that color for oxygen. I guess that looks more orange. So that's oxygen. And then hydrogen, people often will use white, but since white doesn't show up, I'm going to use like a peach. Hydrogen's a lot smaller than oxygen, so the hydrogens are smaller. Now remember, water is polar, so it's got a negative side and a positive side. So the oxygen side is negative, and the hydrogen side is positive. Okay, so we're going to draw a before and after picture. So this is before NaCl, which is table salt, by the way. So this is before it dissolves, this is going to be after. So before it dissolves, like right when you put the salt in the water, but before it dissolves, we're going to have our sodium and our chloride ions still stuck together. And they're actually a lot bigger than the water molecules. We're going to draw some water molecules just kind of floating around here, seeming like they're minding their own business. Okay, I'm just going to label the charges here. Sodium's positive, chloride is negative. Got a negative and positive side for water. Okay, so what happens is the water, since it's polar, since it has a positive and a negative side, it's going to be attracted to these ions. And I only drew 2 water molecules, but there's a lot of water molecules. So there's so many that the water molecules are going to pull these ions apart. So they're going to separate the Na and the Cl. So after they are dissolved, the Na is going to be over here by itself, and the Cl is also going to be by itself, and then some water molecules are going to be attached. So remember, the chlorine is negative, so that means the positive hydrogen ends of water are going to be attracted to it. And then sodium is positive, so that means the negative oxygen side of water is going to be attracted to the sodium. So the water molecules have basically pulled the sodium chloride apart. Okay, so let's talk about what happens to covalent compounds now. We'll talk about, do they get pulled apart or do they stay together? So for a covalent compound, I chose CH3OH. This is methanol. It's a pretty simple compound, but it's something that does dissolve in water. Now, instead of trying to draw all 6 atoms, I'm just going to draw a big oval to represent methanol. So it's kind of simple, but it works. So just pretend this is a carbon and 4 hydrogens and an oxygen. And before it dissolves, so if we put the methanol in the water, it's just going to be in there, just 1 molecule. And we'll draw a couple of water molecules floating around. Okay. Now, this does happen to be a polar molecule, so it's got a negative and a positive side. So it is going to get dissolved by the water molecules. They are going to be attracted to it, but it's not going to break apart into ions because it's covalent. So after, it's going to look pretty much the same, just the water molecules are going to be attached. So if this was the negative end of the methanol, the positive hydrogens would be attracted there. And if this was the positive end of the methanol, the negative oxygen would be attracted right there. Okay, so one thing I want to point out is that this ionic compound, it splits into separate particles. Particles is just a word we use to talk about atoms or molecules, just small pieces of matter. So our NaCl split into 2 particles when it dissolved. But our covalent compound did not split into any more particles. It just stayed as 1 particle. And that is going to be true for all covalent compounds. They're going to stay as 1 particle, but all ionic compounds that dissolve will split up. So I'm going to write that down. Ionic compounds break into 2 or more particles. Covalent compounds stay as 1 particle. All right, so you need to be able to look at a compound and tell me how many particles it's going to break into. So to do this, you're going to have to figure out if that compound is ionic or covalent. So let's start with the first one, NaCl. Na is a metal, Cl is a nonmetal. So since we've got a metal and a nonmetal, that makes this compound ionic. And since it's made of 2 atoms, it's going to split into 2 particles. Pretty easy. Let's try the next one, K3N. K is a metal, it's potassium. N is a nonmetal, it's nitrogen. So again, another ionic compound. This one is made up of 3 potassiums and 1 nitrogen. So that's 4 ions total. So it's going to split into 4 particles. So you can see all you have to do is just count how many atoms your compound is made of to figure out the particles. Now, C12H22O11. Carbon is a nonmetal. Hydrogen, even though it's on the metal side, is a nonmetal. So 2 nonmetals. Oxygen is another nonmetal. So these are all nonmetals. That means this is covalent. Now, a lot of people look at this and they want to say, oh, it's like 40-something particles. But since it's covalent, it's going to stay as 1 particle. No matter how many atoms it's made of, it stays as 1 particle. This is actually sugar, like table sugar. So when it dissolves, it does this. It just kind of gets surrounded by water, but it doesn't break into ions. Finally, CaCl2. Ca is a metal. Cl is a nonmetal. And so it's ionic. And since it's made of 3 atoms, it's going to split into 3 particles. All right, so pretty easy. You just have to look at whether it's ionic or covalent. And then if it's covalent, it's just 1. If it's ionic, it can split into several particles. And that's it. Let me know if you have any questions.